So we've got a horizontal smooth surface, and it comes in speed 8, hits that at an angle of 27 degrees, and that's 8 meters per second it comes in at, and it leaves here something like that. And it's got mass is 0.2 g, and that's it. Oh, E always write down what it is. It's separation speed over approach speed equals 0.6. Find the vertical component of the velocity immediately after impact. So what I'm going to do is I'm going to break this down into two components. I'm going to have a component there, and I'm going to have a component there. I call that A, and I call that B. It doesn't actually matter. And so this is the velocity coming in there, 8. And the first thing we've got to do is we've got to work out what this bit is here. So, and there's an impact in this direction, and so we can work out the separation speed. So we know that separation speed, and that will be, this is my surface, this is the invariant bit. So separation things is how fast does this move away from this surface? It obviously moves away at A. So we're going to get A over the approach speed, which will be this bit here. So that'll be 8, and it will be 8 sine 27. 8 sine 27, and that equals my that's E, which is 0.6. It says so. And actually there we can work it out, the vertical component of the velocity immediately after impact. That is it. That is all I have to do. It's A equals 0.6 times by 8 sine 27, and that equals 2.18 meters per second. That's done the first thing. And the next thing we want to find the magnitude of the impulse exerted on P, and the impulse will be it's like that. Well, it's be, I suppose I could almost do it in green, couldn't I? Because it is impulse, which is force times T, but it's also, more importantly, is change in momentum. And therefore, and we have to be careful with momentum because direction matters. So this part 2, we've got impulse equals final momentum, so mv minus initial momentum, mu. So what's the final momentum? That is the mass times the velocity in that direction. So it's going to be 0.2 times by 2.18, and then we've got to take away our mass 0.2 times by, and because I'm taking impulse to be that way, that means I'm taking that to be positive. So A indeed is positive, which is why I had a positive here. But this velocity as it comes in here, that velocity as it approaches, that is no longer positive because it goes in the opposite direction to the impulse, and so therefore that's going to be negative. So it's times by negative, and then that will be 8 sine 27. Sine, oh I missed out the 8 sine 27, and that equals 1.16, and impulse is Newton seconds, which is not surprising because it's for F times T, which is force newtons times time seconds. And that's question 2 done.